Hello everyone, in this video let me explain you deletion and double linked list. Okay, I hope if you watch this video fully you can understand the concept very well. Okay, in the previous video I have shared about insertion and double linked list. So if you are interested and if you want to continue with this, please watch that video, because if you are into this video before watching that video it will be a little bit collapsing. Okay, so that watch that video and come to this video. Okay, so first hash include std, we are including library fields. Let me move directly into the program. Void inserted beginning. For that I am naming a function. Okay, if head equal to, let me first explain you the concept for insertion at the beginning. Okay, so this is the basically a diagram of that concept. So imagine if you want to delete a node at the beginning, so what will you do? If you imagine a node here like this, what will you do to delete this node? You must delete this node. If this node is a head, you must remove this node and assign this node as a head, right? So the same we are doing. Imagine this is ptr, temporary variable here, so that we are moving this head position to this position, and we are moving this and this that is the ptrs next should be null, and the ptrs previous should be is obviously null, and ptrs next should be null, and this header should point to this, right? So this should be then deleting this. So let me explain you the code. If you consider this relation at the beginning, if head equal to null means what? If head is empty means then there is nothing to delete, right? So that it means that list is empty. Okay, else struct node of temp is struct node of temp, we are assigning some variable here. Okay, so temp equal to head means we are assigning a head as a temporary variable. First we are assigning head as a temporary variable, and then we are moving that head away. Okay, let me explain you. Head is equal to heads next. So consider this as a ptr and this is a head first of all. Okay, then we are moving this head to this, and this remains only a temporary variable, right? So that is the concept. Temp equal to head is equal to heads next. Okay, if head not equal to null means what? If head not equal to null means some element exists, right? If head not equal to null means some element exists. So in case of any element, the previous should be null. So if it is this case, this previous should be null. Since it is head, previous should be obviously null, right? So we are making this also null. I hope you understand. Here this was the head first. Then we have assigned a ptr variable to this. Okay, so we are moving this head to this. Okay, the head to this, and this becomes only ptr. So now this is the head, right? So in case of head, what should be the condition? Head's previous should be null, right? So this should be null, right? So if head not equal to null, make head's previous is equal to null. Head not equal to null means what? There is some element exists in the head position. If some element exists in the head position, make head previous is equal to null, free of temp. So by assigning, so I hope by assigning this as null, this becomes a detached, that is away from this nodes. Okay, so what will happen? This become deleted. So we are freeing up this temporary variable. We have named it a temporary variable, right? So we are freeing up this temporary variable. I hope you understand. Let me explain you from the first. Okay, so if you want to delete a node, first you are setting head as ptr, sorry, ptr any temporary variable there. Okay, so we are setting this as any temporary variable. Then we are moving this head to this. Head is equal to heads next, so this moves to this. Okay, so what will happen? We are deleting this node. For deleting this node, only temporary variable remains here. Okay, that is ptr remains here, head belongs to this node. So if head not equal to null means what? If there is some element exists, what you must do? This head's previous should be null. That is a condition for head, right? Head's previous should be null, then this node gets away from every node, so this should be deleted. That's all. Okay, then free of temp. Okay, why delete at the end? What is the meaning of why delete at the end? Means why delete at the end means if head equal to null, printf list is empty. As I told before, head is equal to null means what? Head is equal to null means this is empty, right? So there is no need of any operations to be done, right? So printf list is empty. Okay, else if heads next is equal to null means what? Heads next is equal to null means, let me explain you here. heads next is equal to null means what? That is the last node, right? So there is no need, that remains the only tail and only head, right? So that only that node must be deleted. No need of deleting, no need of many complicated things. If heads next is equal to null, that is only one node, which is the head and tail, right? So that is only one node, so we are removing that. Okay, free of head we are removing. Okay, I hope you understand. Else we are assigning one temporary variable that we are making at x. Okay, so next, while temps next not equal to null means what is the meaning of temps next not equal to null? If temps next not equal to null means, consider this as the temporary variable. First, consider we are, while moving till while temps next, first we are assigning a temporary variable to this. Okay, then head is equal to temp. Okay, then we are moving the temporary variable till it reaches the last. See, this is first the temporary variable. Okay, temps next not equal to null means while temps next not equal to null means this is the last position. Okay, while temps next not equal to null, temp is equal to temps next till it reaches the last position. Temps next not, this is not the null value, so we are moving to this. Here it is the null value, so we are stopping till it reaches the null value, till the temps next. This is a temporary variable, and we are moving it to the till the last. If it reaches null value, it is temps next not equal to temp is equal to temps next. Then temp, this is temporary variable, temps next, temps previous next equal to null. We are assigning temps previous next equal to null. Why? What is the reason? We are assigning just because we are going to free up this. So we are assigning this as null, and we are removing the link between these two nodes. Okay, so after removing these two nodes link, we are deleting this. So, okay, so that is the scenario here. Okay, I hope you understand. First, let me explain you the code. Okay, first we are assigning a temporary variable for head. Then we are moving it till it reaches the null value. If it reaches the null value, till it reaches null value. Okay, while moving this. Okay, if it reaches null value, temp's previous next is equal to null, free of temp. That's all. It is a very easy concept. Then why deletion at specific position? What is the meaning of specific position? You must enter some position and you must delete the value which is present in that position. I hope you understand. Let me explain you this code. Okay, so int position of I, enter the position you want to delete, and we are getting the position. Okay, if position is less than 0, there is no position, right? So it is invalid position. This is struct node as temp. We are, as we did before, we are creating a temporary variable called temp, and we are assigning it to head, and for I is equal to 0, I less than position, we are traversing till it reaches temp equal to temps next. As I told before, temp equal to temps next till it reaches the null value. Okay, till it reaches the position minus 1, till it reaches the position minus 1, and it should not be null. It should not be null. Okay, it should not be null. Just because if it is null, what we can do, if the temporary variable is null means what, we cannot move into the loop, right? So that is the scenario here. I hope you understand. For I equal to 0, temp not equal to null means and position less than I less than position minus 1, I plus till it reaches temp equal to temps next. Okay, so if temp equal to null means, as I told before, temp equal to null means position out of range. If temps next equal to null, what is the meaning of temps next? Temps next meaning equal to null means it is in the last position. As I told before, as it is in the last position, we can just apply what we can apply. We can just apply deletion at the end, right? So we are applying the concept deletion at the temps next previous is equal to null. Okay, I hope you understand. The same concept, temps previous next is equal to null. What is this? This is temp. Temps previous is this. Temps previous next is this, right? Temps previous next is equal to null. The same concept. Okay, so I hope you understand. Then else, what is the condition? Then we are applying how to remove the node. Let me explain you. Okay, how to remove the node? See, first what we must do means, we must connect this. See, this figure is given wrong. Let me explain you by my words. Okay, consider this PTR as temp. Okay, listen to my audio. Okay, consider this PTR as temp. If you consider this PTR as temp, what you do? PTR's previous next should be connected to this PTR's next, right? So let me explain you the code. Okay, PTRs, sorry, that is temp. Okay, temp we are containing. Temps next previous is equal to temps previous, as I told before. Temps next temps, this is temp, this is not temp. Temps next previous is equal to temps previous. What is this temp? Temps previous. So, as I told before, this must contain the address of this link, link, right? So, that is the concept here. Temps next, another temps previous next. What is this? Temps, this is temp. Temps previous next is equal to temps next. What does that mean? What is the value of temps next? This is the address of what node? This is the address of this node, right? So if you go deep into the concept, you can understand. Let me try to explain you to my fullest. Okay, this is temp, right? Temps previous. What is temps previous? Temps previous, this is temps previous. Temps previous next should contain the address of this node. That is, this node is this node address is contained in this, right? So this contains this address. You, how to explain it? Okay, so this is temp. Temps previous next equal to temps next. So this node should be connected to this node. That's all. It's concept. And this node should be connected to this node. That is the concept. This is what temps next previous. This is temps previous next should be connected to temps previous next should be connected to temps next. That's all. Then temps next previous is equal to temp previous. Then the next concept are insertion and the insertion concept. Insertion concept, as I told already in the previous video. If I take that too in this video, it will take nearly an hour. So let me finish this by displaying the output. First, let me teach you the code for void display. Struct node as strict temp. Temp is equal to L if while temp not equal to null. That is still it reaches null value. You must print temp data, then temp equal to temps next. You must continue the loop. Okay, so into data and structure we are assigning as previous and next, and head we are assigning it as null. Okay, so we are running the program. Okay, so enter the sorry, you cannot understand, you cannot see. Okay, adjust this. Okay, so enter your choice. I'm adding insertion at the beginning, so let me add insertion at the beginning for everything like this. Okay, enter the data you want to add. Enter the data I want to add 1. Enter the data 2, 1, 2, 1, 4. So okay, then I must delete. Deletion at the end, deletion at the beginning. Let me do first. Deletion at the beginning, deleted, right? 4 is deleted. Deletion at the end. Deletion at the end means what? 5. See, 1 is deleted, right? Deletion in any specific position. Any specific position 6. Let me enter any specific position 2. So only 3 is there. So okay. So this is the concept basically. So I hope you understand. I hope I thought clearly. So if you cannot understand still, please ask me. So thank you for watching this video fully. Thank you.